Okay, so we're going to go over recognizing functions from tables. So this is basically an extension of what we're doing when we graph them by hand, and for them, we are going to have another unit that's all about how to graph them. I just wanted to get you like an intro to it, so like just put that on the side. It's useful, but it's not like our critical point here. We're just going to be able to look at our functions and our tables and figure out what's going on with the functions. Our goals are to be able to graph a function using a table. That's an extension of last time's. We also want to identify functions from data on the table, so we can look at it and say, oh, hey, that looks linear, or that looks quadratic. And we also want to compare functions using data on tables, because it makes it easier for us to see like the differences and what's similar between them when we can look at actual raw data and say, oh, wow, that's a really big difference. Like that's increasing a lot faster than this other type of function is. So we're going to go through some dance moves and remind you of them. Basically, remember we can predict the shape of a graph based on the type of function. So for our linear functions, which we have an example of here, we throw our arms up in a diagonal slant, so it's a nice little line. It's of the form y is equal to mx plus b. Next we have our quadratics, and remember our quadratics are going to have like this little loopies. You're just basically a giant U. This is going to be somewhat of the form of y is equal to ax squared plus bx plus c. Basically, you need to have that x squared in there for it to be a quadratic. And our exponentials, those go from really low to really high. They grow really fast. These are going to be of the form y is equal to like some number to a power, and that power is going to be a variable. Yes, you're going to see something like 2 to the x. Essentially, you have to have something, the variable in the exponent. So let's go over and compare some of these functions real quick. So a linear function has a variable and no exponent. Here are some examples. Y is equal to 5x plus 1. So here our variable is x. X is a variable with no exponent. It's just the first power. We can also have y is equal to 1/2 x. So again, your x is like it doesn't have an exponent on it, so it's a linear there. Now we have 2x plus 3y is equal to 6. This one's a fun one, so it doesn't look like it would necessarily be linear, but you can rearrange and solve that y is equal to something, and so you get y equals to 2x plus 6 divided by 3, and your x is still going to have only the variable there. Let's look at our quadratics. So our quadratic, the rule is that the highest power has to be squared. So you can have it as just like an x squared, you can have an x squared plus x, you can have an x squared plus x plus some number, but whatever, in order for it to be a quadratic, or here we'll write another one, it's parabolic, that's the name of the shape, it has to have the highest power being squared. I'll put some examples down real quick. We have y is equal to 2x squared minus 3x minus 5. You notice here that our highest power is our x squared, which means that it is quadratic. We can also do x squared plus 4y is equal to 7. Again, this one you just have to rearrange so that you get y is all by itself and y equaling something, and then that will work. That's since it only has the x squared, that'll be quadratic. Here's another interesting one. You have y is equal to x minus 3 times x plus 4. This one, if you're to FOIL it out, you'd end up with x times x, which is x squared, which is why it counts as a quadratic. Now our exponential, it has a variable in the exponent. That's all that you need to know about it. Some examples are like y is equal to 3 to the x plus 1. We can also do y is equal to e, and remember that's Euler's number to the x. Or we could do 4x plus y is equal to 13. Remember, if it doesn't look quite like it, you just rearrange it, and then it should work. So go ahead and take a moment. I want you to pause the video, and when it's paused, I want you to state whether each of these functions is linear, quadratic, or exponential.